Okay, now members are going to handle this one. It says a body falls from rest from the top of a tower, and during the last second it falls 9/10 of the wall distance. Find the height of the tower. So what do? We draw a simple sketch. Now this one you have to be careful because this one is just falling down from the top of that cliff. We don't know this cliff, but we know it's going to be having a certain height. So this is our cliff. So we are assuming now something is falling off. Of course, when it's falling off, it has to come down like that. Now, at this point here, what is falling off? We assume that now, let us call this to be our edge, the height of this cliff from the ground there. Let us call it edge. Now, when it's falling, remember it's falling from rest. What does it mean? It means that now, from here, our u is equal to 0 meters per second, the initial speed. Why? Because it's falling from rest. And then in the last second, now here when we bring in the nth second, remember the nth second? In the nth second, we said the nth second displacement, we said is given by Sn equaling Sn minus Sn minus 1, the nth second. So now this time, I think that's the last second, they are dealing with time. So we are going to call it our ST3. It's going to be ST, then minus ST minus 1. So now we need to call this. That means that at this, our ST is going to be 9/10 of the height. But before we go to that, down, so we have our distance from here, so our S here is going to be H. The distance this particle is going to cover, that's our initial velocity. So now it's going down. So now here, because it's starting from here, now it's falling. So mean that there our acceleration is going to be D. So now, if we start here, we know that our S is equal to UT plus a half AT squared. So our H is going to be 0 into T, then plus a half D. Now our D, T squared, which will be H equaling to a half 9.8 T squared. So our H here is going to be 4.9 T squared, and I call this equation 1. Because in acceleration due to gravity is 9.8. That's what it is. Now after that, we want to get this. Now I think that this displacement here, when the particle in the last second, which we call it T, is going to be this. Now we first get this. So from there, by telling us that the whole of this, the T second is going to be 5 over, is it 5? It's 9. It's 9/25 of the height of the whole distance. The whole distance, this one is supposed to cover. So now if we come here and get our ST. So for our ST, we are going to be having now UT plus a half. Now remember, our acceleration due to gravity, we say it's going to be positive because it's falling. Whenever it's falling, from the start it's falling, it's there, positive. So D, then T squared, which is going to be from here, UT plus a half 9.8 T squared. So from there, you can able see my ST is going to be UT plus 4.9 T squared. Then I also come and I get my ST minus 1. ST minus 1 is going to be now, from here now, we are just substituting in this formula. So I have U into T minus 1, then plus a half 9.8 into T minus 1 the whole square. So can you simplify this? This will give us UT, but in our T, our U of course is 0, but we shall come to that U. Then plus a half 9.8 into, when you simplify this, T squared minus 2T, then plus 1. When we simplify this, so our ST minus 1 here is going to be U, 10 minus 1, then plus, this one is going to be 4.9, multiply it there, 4.9 t squared, minus 4.9 times this we get 9.8t, then plus 4.9. So, but remember, this is our st minus 1, but our u is equal to 0. So meaning our st from here, which was ut plus 4.9 t squared, our st here is going to become 4.9 t squared. Then our st minus 1, which is u into t minus 1 plus 4.9 t squared minus 9.8t plus 4.9. Our st minus 1 is going to be now 4.9 t squared minus t plus 4.9. From here, because our u is equal to 0, so this vanishes, so it remains with that. Now, the thing is that now the whole of this st minus 1 is going to be 9 over 25th of the whole height. The whole height is, so you just substitute. This is going to be 4.9 t squared minus, now 4.9 t squared minus t, then plus 4.9. There, the whole of that is equal to 9 over 25 h. So what am I going to do is that when I open bracket, this will vanish. I'll be having here. This is going to be, when I open brackets, this will be now. Okay. People will ask, how is it vanishing? Let us open brackets now, plus t, this next element is 4.9 equal to 9 over 25 h. So now, this one is vanishing with that. What are we remaining with? We are remaining with, now remember that our 9.8t minus 4.9 is going to be equal to 9 over 25 h. Now, remember from 1 here, but from 1, you know that our h was given by 4.9 t squared. So substituting it here, is that if I multiply it by 25, okay, I'm going to be having t minus 4.9 equal to 9 over 25 into now 4.9 t squared. Divide through by 4.9. Divide through by 4.9. When you divide it here, you'll be having 9 over 25 t squared. When you divide it here, you'll be having plus 2t. Divide it here, you'll be having minus 1 equal to 0. Multiply it by 25, have 9t squared plus 50t, then minus 25 equal to 0. Two numbers I add, I get 50. When I multiply, I get 9 times 25. So the product here, 2 to 5. Which values is there? When I add, when I take it the other side, the signs, not, when I divide through by them, then I take the other side. Okay, maybe I shouldn't skip that step. So that people can able to follow properly. Okay, now I think you see, when I divide through by 4.9, this side I have 2t, then minus 1. When I divide here, I get this. When I divide this by 4.9, I get this. When I divide it here, when I take everything this side I have 9. Okay, but let us first multiply by 25. 9t squared equal to 50t, then minus 25. Bring everything this side. 90 squared minus 50t, then plus 25 equaling to 0. When I multiply two numbers, I multiply, the product is 2, 2, 5. Two numbers I multiply, but it should be always, not the factors are going to be always based on this, and just get the factor. So the factor first of all should be of 9 and then a 5. So what does it tell me there? So that I'm going to be having first of all 45, and then I need a 50. Yeah, that's it. So this one, because this is positive, all of them should be of the same sign. Because this is positive, remember the moment this is positive, all of them should be the same sign, either positive or negative. If it's negative, now they are different sides. But because it's positive, and it's that this is negative, meaning all of them are going to be negative. So putting it here, equal to 0. So 9t is common here. I have t minus 5. Get this divided here, get 0. You get this divided here, you get 5. Then minus, so I need t positive, and tries out negative 5. When you divide negative 5 here, you get t. When you divide negative 5 here, you get negative 5 equal to 0. So either t minus 5 is common. So that either 9t is going to be 5, and then 9t is going to be 5 over 9. Okay, from there what happens? Now, we are going to take our t to be 5, because if we are dealing with the nth second, and we subtract from this and a 1, so we are going to have a negative, and we cannot have negative time. So therefore, our t is going to be 5 seconds. So after that, they're asking to find the height of the tower. How do you get the height of the tower if we have time? So our height of the tower from there. So our height is going to be 4.9 t squared. It will be 4.9 into 5 squared, which will be 25 times that. It's going to be 1 to 2.5 b, and that will be our answer there. So that's how we handle that number. Here the conclusion is, because when I get t minus 1, this one will give me positive, this will give me negative. From here, the nth second. That's why I'm taking this one, because I can never get time when it's negative. So that's it, members. Wish you well.